Okay, the standard convention when labeling triangles for solving is that the angles are lettered capital A, capital B, capital C, and the sides opposite are small letters with the same letter. So C, little side C is opposite big angle C, little side A is opposite big angle A, etc. Now, some textbooks use alpha, beta, and gamma for the names of the angles. And in that case, A is opposite alpha, B is opposite beta, and C is opposite gamma. All right, so now if we try to sketch a triangle where gamma is this obtuse 120-degree angle, you can label either angle alpha or beta and just label the sides accordingly. Alpha is 30 degrees. Well, when you know two angles of a triangle, it's easy to find the third angle. Add them together, 150, to subtract from 180. 180 minus 150 is 30. So in fact, this is an isosceles triangle because the base angles are congruent. But how can you find alpha and or A or B? You have to use the law of sines because you know an angle and the side opposite. So A is the 30, sine of 30, has 88, which is C, is to the sine of its opposite angle, 120. And if you solve for alpha, you get 88. I'm sorry, if you solve for I should have A's here, not alphas. Put a little A here. A is equal 88 sine of 30 over sine of 120. Now, you're supposed to do this without a calculator, and you can do that because 120 and 30 are special angles. You can get it from the unit circle, or you can draw a little right triangle here where the sides are in the ratio 1 to square root of 3. In a 30, 60, 90 right triangle, hypotenuse is twice the short leg, and the long leg is radical 3 times the short leg. And if you want to get the sine of 120, you picture the unit circle or a circle rotating into the second quadrant. The reference angle is 60 degrees. Put the same ratios on here, although in the second quadrant this is negative. The x coordinate is negative, but the y coordinate is still radical 3 over 2. Gives you the sine of 60. So there we go. That's what I did right here. I substituted sine of 30 as a half. Sine of 120 is radical 3 over 2. Half of 88 is 44, and then I multiplied by the reciprocal of the denominator, 2 over the square root of 3. And then I rationalized by multiplying top and bottom by radical 3. And there is the exact value for the length of side A. And B will be the same. You could also do it this way, B over the sine of 30. But there's no need because you realize it's an isosceles triangle. And here's proof. 88 over the sine of 30. 88 times the sine of 30 over sine 120 is about 50.8. And 88 radical 3 over 3 is the same thing. So there's your answer right there. Okay, hope that helped. If you have any questions, post a comment.